Hello everyone. Let us continue learning C++ programming. In our previous video, we discussed about inheritance, types of inheritance, and polymorphism. And also we discussed a lot about different types of casting and the purpose of dynamic casting. And we also came across a topic of virtual functions and pure virtual functions, which are the key components in abstraction. In this video, we are going to see in detail about abstraction in C++ programming. Let's get started. Now, abstraction is one of the key features in any OOPS language, especially languages like C++, Java, and Python. Abstraction means displaying only the essential information to the user and hiding the details which is not needed for the user interface. Data abstraction refers to providing only the essential information to the outside world and hiding the background details of the implementation. For example, we can talk about CIN and cout objects in C++ programming, both of which is implemented in order to read input from the standard input screen as well as to print a certain data to the standard output screen. In such cases, none of the implementation part of how the value is being read, how the data types being defined, and how the values are being printed to the screen is displayed to the user. Rather, only the usage of both CIN and cout is being done. The rest of the implementation part is completely hidden out in terms of the standard libraries at the back end. And this style of writing the whole code where displaying only the essential information to the user or the outside world is called as abstraction. For example, consider a real-life scenario of you driving a car. Now, what happens when you press the accelerator? We all know that when we press the accelerator of the car, the speed of the car gets increased. But what is the background implementation of pressing the accelerator does? That is completely hidden from us. And similarly to that of the stopping the car by pressing the brakes. So what happens at the background of while we press the brakes? How the energy or the power is being shifted from the engine towards the braking pedals is completely hidden from the outside world. And this is yet another a quick real-time example which we can have for our data abstraction part. Now, to add more technical details about abstraction, now in order to perform abstraction in C++, we make use of classes. The classes helps us to group the data members and the member functions into one single unit, which are then accessible by the user with the help of objects. And a class can decide which data member or the member function should be outside to the world and which are the data members as well as the member functions which should be hidden from the outside world, which is done effectively by the use of access specifiers. For a quick instances, let us create a simple code and see how the data abstraction is done in terms of C++ programming. So here I would like to create a file with the name abstract.cpp. So I'm starting with the basic header file include of IOStream and using my namespace, which is the standard namespace. And here I'm going to create a base class which has private data members. So specifying it or not specifying it makes no difference because by default, if we are not specifying any access specifier for a class, the default access specifier for a class is set to be private in C++ programming. So I'm creating a member of X and under the public function, under the public access specifier, I'm creating a base class constructor int val is equal to 0. So this acts both the way. This base function will act as the default constructor as well as the parameterized constructor, where I've had a default argument value of val which is equal to 0. And that value will be copied to the member variable of X. And also I have a put function with the return type of void. And that simply prints the value of X to the screen and ends with the new line character. And any declaration in C++ programming should end with a semicolon. So I'm ending it the same way as it is supposed to be ended. And I'm creating my main function here, which is the user-defined function in C++ programming, under which for the base class, I'm creating an object with the name of obj. And with the help of obj, which is an object of base class, from the outside world, that is from the main function, I'll be able to call only the base constructor, which can be called here with the help of function brackets, base object of 6. And yet another function which is accessible from the outside world is the put functionality. and there is no way of me accessing obj.x, which is a private member of the class. So this access will not be successful, which will end in an error scenario, for which I'll compile this code and show you what is the error message you get. G++ abstract.cpp -o abstract. The compilation part, here you see an error message saying the base X is a private member. So this particular object of X, which is a data member, which is basically a private data member for the base class, is completely hidden from the main class, which is considered to be the outside world scenario. So this access is not possible. Now, from the perspective of this object, which is a base class object, which is present inside the main function, only two components are accessible. One is the constructor, another one is the put functionality. And this idea of hiding certain details to the outside world and passing only the needed files, needed functions, passing only the needed functions or the data members to the outside world is called as data abstraction in C++ programming. And when we compile this code, the compilation seems to be successful. And when we run the code, we can see the value of 6 being printed. So the execution here is successful, and this clearly shows how the abstraction in C++ works. And what about abstraction using header files? The yet another type of abstraction in C++ is by usages of header files. For example, we make use of some of the mathematical functions like power, square root, absolute, ceil, floor, and there are a lot of other functionalities we make use of, whose implementation is not seen to the outside world. Rather, all these implementation of such functionalities are hidden behind the implementation of the header files, namely math.h, or some of the string functionalities like string length, string comparison, string concatenation are hidden behind the implementation of the string.h header files. In such cases, these are also quick components or quick methodologies of data abstraction and C++ programming, where the implementation part are not hidden by the user-defined classes, rather they are hidden out in terms of header files, which are basically the pre-compiled or pre-defined header files. Now, what are the advantages of using data abstraction? Number one, it helps the user to avoid writing low-level codes. Number two, it avoids the code duplication and also improves the code reusability. And also it can change internal implementation of the classes independently without affecting the user. And data abstraction majorly helps in improving the security of the application or program, as well as only important details are provided to the user. And that's it all about data abstraction in C++ programming. Hope the ideology of data abstraction is clearly understood. See you in the next part of the video. Thank you.